So when the mean of rain was 1, the outdoor activity was 10, right? It was here. So that can be considered as the strong negative correlation. When R is -1, that is strong negative correlation, and when R is equals to 0, that is no correlation. Hello friends, welcome back to another day of grind, another day of hustle. Day 39, or we can say T-62. I'm trying to achieve the Purusharth. I know I cannot achieve the Purusharth, but we can try. The meaning of Purusharth in Srimad Bhagavad Gita is the human goals, the highest objectives of a human life. That's the point of discussion of another day. I'll discuss that in future, the Purusharth, but we should try our best. We should definitely grind and hustle. So today we will cover one of the most important topic of the quant, we can say, that is the covariance and correlation. Because with the help of these concepts, you will be able to perform so many amazing things. Like it will help you in portfolio diversification, it will help you in market analysis, and it will also help you in risk management. So now you can think that how important this topic is. We will understand this thoroughly, and I also tried my best to collect so many examples, so many real life examples, so you can really understand this topic and you can use in your real life trading. Today also I was able to wake up at around 2:30, and after that I took a little bit more time so that I can give you the best example. So right now it's around 5:55, you can see, and I took around 3 hours to prepare the content, to structure the content so that I can explain you more precisely. So without a further ado, let's get started. So first of all, where we use the covariance. So generally what happens when we have a categorical data, we can draw a contingency table or a cross tab. And when we have a categorical and numerical data, we can draw a box plot. And we have also discussed this, that when we have numerical column, we can draw a scattered plot. So now what happens, so when we have two numerical columns, so we can easily draw a scatter plot, but in real life we have to find the exact relation between them, right? What is happening? So let me tell you with the help of an example that why we need the covariance. So what I'll do, I'll draw a table, and in that we will assume the temperature of two countries. So let's say a country in Africa and another country, let's say it's Sweden, right? And let me draw the table. So now what happens, let's say in Africa, what happens, the temperature ranges from -3, 0 to +3. But in Norway, it ranges from -30 to 0 to +30. Just the example, right? So now, if I want to take the mean of this, what will happen? -3, 0, +3 over 3. And for this, it will be -30 plus 0 plus 30 over 3, correct? And the results will be 0 and 0. So as per the mean, there is no difference in the temperature of Africa and Sweden, but that is not true. We know that there is a difference, and in these cases, the mean is not helpful. So we need some another utility which can help in these kind of cases, right? Because mean will give us only the centrality. It will not give us the spread, right? It cannot tell us that what is the spread of data. Similarly, it can be used everywhere. So means as per the mean, the center of both the countries, Africa and Africa is continent, by the way. So both the continent Africa and country Sweden is 0, but we cannot find the spread. So in order to find the spread, we have discussed that we have variance and all the measure of dispersion, right? So now to find the relation between these two variables, so that when they changes, what is the relation between them? So we need to have a matrix which can tell us that this is the relation, this is positive, negative, or neutral. And for that purpose, we will be using the covariance. And let me tell you what is covariance. I'll upload the definitions and all the text material in the GitHub, so you can download from that. But for now, I'll not repeat all the definitions which you can find anywhere, right? I just want to make you understand with the intuition, not with the text and definitions, right? So yeah, please focus. So what is covariance? It measures the degree at which two variables changes together. Now we can have two variables like the stock price of A and B, like the volume of A and B, or you can say the relation between the temperature and the stock prices. Like you can find any kind of relation. It's up to you, right? So what happens? Let's say if X is increasing, right, and Y also increasing, then we will say the covariance is positive, right? Covariance is positive. Similarly, if X is increasing and Y is decreasing, then we can say covariance is negative. And like if there is no impact, even if X is increasing but there is no change in the Y, then we can say it is neutral. That's simple. The formula for covariance is covariance of X and Y is summation of I equals to 1 to n, then X minus X bar and multiplied by Y minus Y bar, right? X bar is the mean, right? Then over n minus 1. This is the formula for covariance. Now, where you can see that X and Y are the variables, let's say you have this table, right? And here you have price of stock A and price of stock B. Then you can say these are the variables, right? A and B, X and Y. And then you will find the value of whatever the value is, and then you will find the mean and you will plug in all those values in this formula and you will get the results. We will do that shortly, but before that, let me show you this with the help of an example. So let's say for the positive covariance, let's draw a graph, and this is x-axis, this is y-axis. So if X is increasing, Y is also increasing, let's say, right? If X is increasing, Y is also increasing. So you can say this is the positive covariance, right? Similarly, for negative, this is X and Y. If X is increasing, let's say you were here when X, right? If X is increasing, then Y is decreasing. Let's say here, then on the X, it is here, and then here. Means if X is increasing, then Y is decreasing. That means there is a negative covariance. Similarly, for the neutral, what you can say? You can say that when X is increasing, there is no impact on the Y. Let's say X increasing, but Y remains same. And that is known as the neutral covariance, right? So these are just the example plots. And now we will understand this with the help of an example. Okay, so this example is very famous, the sale of ice cream and the temperature. So whenever the temperature increases, the sale of ice cream increases, right? Let me show you how. Let's say we have ice cream and temperature, right? So we have a table here. This is day, this is ice cream sale, this is temperature, and okay, let me write here day 1, 2, 3, 4, 5. Then we have temperature. Let's say it was 30, 35, 40, 45, and 50. This is the ice cream sale, right? So let's say first day it was 10, then temperature increases to 35, it became 20, then it became 30, 40, and 50. Okay, so now as we are trying to find the covariance, and we have seen that the formula for covariance is, let me again write it. Formula for covariance is xy and then summation of I1, and here the division of variable A, that is x minus x bar, and then division of variable B, and we will multiply that, and then n minus 1, right? So here we will find the division of variable A, that is x minus x bar, and here division of variable B, and here we will find the product, right? So y minus y bar and product of division of variable A and variable B. So you can write here like x minus x bar multiplied y minus y bar, correct? So let's understand this. So first of all, what we'll do, we'll find the mean of both of these x bar. So it will be around, let's say 50 plus 40, 90 plus 30, 120, 120 plus 80 is 200, 200 over 5, which is 40. The mean of this is 40, and the mean of ice cream is 90, 120, 150 over 5, which is 30. Okay, now let's populate these values. So the first will be 30 minus 40, which is minus 10, 35 minus 40, which is minus 5. This will be 0, this will be plus 5, and this will be plus 10. Correct? Similarly, for this it will be minus 20, minus 10, 0, then plus 10, and then plus 20. Now let's multiply these values. So it will be 200, 50, 0, 50, and 200. Okay, now let's populate these values in this formula. So what it will be, we have already calculated this value, right? This one, this is here. So we'll just add these values. So it will be, let's add this, 2 plus 2, 4 plus 5. It will be 500 over n minus 1. N is 5, and then we'll get 4. 1, 2, and 5. Means the covariance is 125, which is highly positive. So now we can clearly say that covariance is positive here, right? And we can also draw this on the chart. So let's say we have this chart here, and on the x-axis we have the temperature, and here we have the ice cream sale. So on temperature we have 30. So when temperature is 30, let's write like this: 0, 10, 20, 30, 40, and 50. Similarly, for this also 10, 20, 30, 40, and 50. Right? So when temperature is 30, it is 10. When 35, it is 20. When 40, it became 30. 45, it became 40 around, and it is 50. So we can say there is a linear positive relationship, and whenever the temperature is increasing, the sale of ice cream is increasing. So there is a positive covariance, right? Similarly, we can find for a negative covariance, let's say a rainy day and the outdoor activities. So let's do that quickly. I'll proceed very fast in that. What we'll do, we'll draw a table, rainy day and outdoor activities, right? So for that, we can quickly draw a table, and day, the mean of rainy days, the outdoor activity, the deviation of x, deviation of y, and the product of that. So it will be like this: day, then mean of rainy day, then outdoor activities, the deviation of x, the deviation of y, and the multiplication of both. So let's say 1, 2, 3, 4, 5. So if the mean of rainy day is, let's say, 1, the outdoor activities are 10. If the mean is higher, 2, the outdoor activity is 8. If the mean is 3, it becomes 6. If the mean is 4, it becomes 4. And if the mean is 5, it becomes 2, right? Now, what is the mean of this? 5, 4, 9, 12, 15, it will be 3, and 6, 12, 20, 30, and it will be 10. So now when we write here, it will be minus 2, minus 1, 0, plus 1, and plus 2. Similarly for this, it will be 0, minus 2, minus 4, minus 6, and minus 8. The product of this will be 0, plus 2, minus 4, minus 6, and minus 16, right? So, okay, now let's calculate this. It will be 22, 26, and 24. So it will be minus 24 over 4. So it will be minus 6. Means it is negative, right? We can even plot this. Let me do that quickly. So let's say it was a rainy day and it was outdoor activity. So, and the scale is 1, 2, 3, 4, and 5. And this scale is, let's say, 2, 4, 6, 8, and 10. So when the mean of rain was 1, the outdoor activity was 10. right? It was here, correct? When it was 2, it was 8, so it was here. When it was 3, then the outdoor activities were 6. Mean of rain was 4, it was also 4. And when mean was 5, it became 2, right? So you get the idea actually. And now you can see that it is decreasing, and that's why you can say it is negative covariance, right? Hopefully it's clear. Okay, so now the main thing is that we are able to find the direction, whether it's positive, whether it's negative, or whether it's neutral, right? Covariance is good. We are able to find the direction, positive, negative, or the neutral. But the biggest problem of covariance is that we cannot find the strength. We cannot find the magnitude, that how strong the relation is. It will just tell us the negative and positive, but it is not a reliable measure for this strength. I'll show you how. You will find all the theory and examples in the GitHub. I'll post everything. But for now, just focus on the understanding. And if you want me to change something, please let me know in the comments and we can discuss that, right? So, okay, so you can see the theory here. And why we use covariance? Because we can use this in the portfolio diversification, we can use this in the risk management, and we can also use this in the market analysis, right? The pros are that the risk is reduced with the help of this, definitely, sometimes, at some extent, for the better portfolio construction. And when we perform the hedging, it is informed, right? And the cons are, it doesn't measure the causation, and it is very sensitive to extreme values, and it is static in nature. Okay, you can see here, we downloaded the data from the Yahoo Finance and we calculate the daily change. And here is the scatter plot of that, right? And you can also see the covariance matrix, which is positive, right? And the next plot is for the negative covariance. You can see here the relationship between the SH and SPY, right? And the third one is for the neutral, like there is not much covariance between these two values, Microsoft and KO. Now let me tell you the problem. The problem, what I will do here, okay, I'll just copy this one, the SH and SPY, and I'll show you the problem. The main problem is, okay, I'll add some code here. And okay, what we'll do here, we have this data, right? Let me show you what is this. For now, I'll just comment all these, and then here I'll print the data. First, it says YF is not defined. Okay, now let me again run this, and you can see that we have SH SPY data. So what I'll do here, I'll just multiply this data. So I'll copy, for now let me uncomment this, and I'll copy the same code and paste in next cell. And here also, I'll again comment it out for now, and I'll multiply the data with 2, right? So I can give it the name M data, multiplied data, right? Now when I print this M data, we get this value, right? These all are doubled. Here it was 14, now we have 29. Or let me do, I'll just multiply this with 20, or let's say 200. Okay, now we have all the values multiplied by 200, the same data. Okay, now let me write it here. Let's say I'll just replace all the data with the M so we can have a clear picture, and I'll do it M data. Right, okay, rest everything is fine. Okay, and let me draw this. So hope you are able to get my point. We have a data original, right, which we download from the Yahoo Finance. Okay, now let me again draw the scatter plot and the covariance matrix. So which is this one, right? This is the negative covariance and the covariance matrix, right? After multiplication with 200, now let's draw it again. So when I hit shift enter, we get the same negative covariance. You can see here, it is exactly same. Means even if we have two columns with different data, we can just have a direction. We cannot have that how strong the relation is. That is not the reliable measure of the strength, of the magnitude, right? Hope you are able to get my point. What I'm trying to say, that we can only know the direction with the help of covariance, not the strength. That is the major issue with the covariance, right? You can see here, the scatter plot is exactly same. There is no difference. Even if you multiplied the data with 200, right? Now, in order to resolve this issue, what we have correlation. So now we'll understand the correlation. So before that, what you can do, you can download the GitHub and refer all these theoretical part if you want, right? You will understand more that why it is required in terms of quant finance, right? So I specifically added this data into the GitHub, and you can take the advantage of that. Okay, so now let's proceed to the correlation, that how it helps us in finding the direction as well as the strength or magnitude of the relation between two variables, right? Okay, now let's understand the correlation. So before that, let me tell you one more thing about covariance. That is, if someone asks you that what is the covariance of a variable with itself, right? Earlier we have done about the covariance between two variables x and y, but what is the covariance of a variable with itself? So let's say you have a variable x, and if someone asks you to find out the covariance between x and x, so what you will do, we have the formula, that is summation of 1 to n, then x minus x bar, right? Now we do not have any y, so it will be again x minus x bar upon n minus 1, and it will become I1 x minus x bar squared n minus 1. And if you're able to remember, this is the formula of variance. So we can deduce that the covariance of a variable with itself is the variance, right? Okay, now the problem of covariance we have discussed already, that it only tells the direction, the positive, negative, or no relation. But what if we also want the strength, that what is the magnitude of this relation? So in order to find the solution of that problem, we have correlation, right? So let's understand that. So first of all, I'll show you different types of relations. So let's say we have a strong correlation, right? Strong positive correlation, right? So for that, we can draw a graph like this, x and y, and here it is like this, right? We have discussed this already. This is the strong positive correlation. Then what about the strong negative correlation? For that also we have discussed the x and y, and when the relationship is like that, when x is increasing, y is decreasing, right? So that can be considered as the strong negative correlation. Then we have is weak negative correlation, and the fourth one is, it is weak negative, and that is weak positive. So it is weak negative and that is weak positive, right? So for that, how we can draw? Let's draw the plot. So for weak positive, we will be having a relation something like this, like the dots will be scattered a little bit like this, right? This is positive but weak positive. Similarly, for the weak negative, we can draw like this. There will be negative correlation but not as strong, so it will be like this, right? Hope it's very clear. Now the last one is no correlation. So for that, how you can draw no correlation, right? So for that, you can simply draw like this, x and y, and you can draw like there is no pattern, you can say, right? There is no pattern. Okay, now let's understand the definition and formula of correlation. So let me write it, correlation. And what it does, it finds a direction of the relation of two variables, and it also gives us the strength, or you can say magnitude, right? Then what is the formula of this? So what we'll do, we have a formula for correlation coefficient, that is covariance of x and y, and then standard deviation of x and y. That is the formula of correlation coefficient, and r ranges from 0 to 1, right? So when r is equals to 1, that is strong positive correlation. When r is negative 1, that is strong negative correlation. And when r is equals to 0, that is no correlation. Hope it's crystal clear. It's very straightforward formula and definition, right? It can be also used when we are diversifying our portfolio. It can be also used for risk management and also for the market analysis, right? Now, in order to demonstrate this correlation, I have few charts. Let me show you. So for the definitions, you can refer this Jupyter notebook on GitHub. Then, so you can see here the scatter plot of Microsoft and Apple. So now to understand the benefit of correlation, what we'll do, I'll just copy and paste this code here and I'll add it here. And what I will do, first I'll just comment out this and first check the return data frame, like what is the value inside this. So in the returns data frame, we have the percentage returns, right? And now what I'll do, I'll just uncomment this for now. I'll remove this from here and copy and paste here. And what I will do, instead of this returns, I will multiply it with 2000, assign it to a new variable, that is, and now we'll plot everything for the m return. So wherever we have the returns, I'll change it to m return, and here also m. Okay, so now let's draw both of the data frames. So here we have this one, right? This is the magnitude 0.02, negative to positive. Here also the same, right? This is the matrix. Okay, now we have multiplied the data with 2000, and when I run this, you will see that we have minus 42, 40, and here also we have minus 42, 40. So now we have both the direction, that is the negative, and the magnitude, right? I hope it's very clear the difference between the covariance and correlation and the benefit of the correlation. But correlation is for the direction as well as the strength or magnitude, right? Now you can refer all the different examples I have pasted here. So it will be beneficial if you are having any difficulty, like the box plot with the scatter plots. Okay, now there is one more very important thing to note, that correlation doesn't imply causation. Let me write it. Correlation doesn't imply, very bad doctor's writing, doesn't imply causation, right? What does it mean? It means that if two variables are associated with each other, it doesn't mean necessarily that they are causing each other, right? Means one is not the cause of other. Okay, let me show you with the help of an example. For example, there was a study which found out the number of hours a student spending in the video game and their academic performance. So that doesn't mean that if he's spending more time, then his academic performance will be increased. There is no relation, right? It is highly possible that there might be some other reasons. If he is not playing games, then he might be doing something else, and because of that, he is not performing well in the exams. And even if he is playing a lot, then still he can perform well in the exams, in the academic. So there is no correlation. Means sometimes what happens, people get confused and they mix up the correlation and the causation, right? So you have to be very mindful of that fact. Now, the example of causation. It means there was a controlled research in which the scientist, the example of causation, the second one, in that what happens, there was a controlled experiment which shows that a use of a new fertilizer help in the increased growth of the plants compared to when we are not using the fertilizer, there was less growth, right? So here we can say that yes, these two variables, the plant growth and the use of fertilizer is correlated and it is causing each other. Because of the fertilizer, the plant growth is increasing. So you have to understand the exact difference so that you do not mix it up, right? So yeah, that was the basic explanation.